We're going to begin talking about exponential functions, and it's called an exponential function because it has the keyword exponent, and that's going to be very important when we talk about all of the key features that go along with exponential functions. Now, exponential functions are different from linear, so if you remember when we were looking at linear, you do not have to write this, but a lot of times with linear, we would add or subtract by the same number. So if I was going up by 5, I'd say plus 5 plus 5. So linear was constant because we were adding and subtracting by the same amount. So it was the same amount of change every single time. Well, exponential is different because it is not going to change by the same amount every time. It's going to multiply. So if I start with 5 and I multiply by 2, that's going to give me 10. But then if I multiply by 2 again, that's going to give me 20. And I can keep going. I can multiply by 2 again and give me 40. So exponential, which is what an exponent is a shortcut to multiplication. Because if I have 2 raised to the power of 3, that means 2 times 2 times 2 3 times. So an exponent is a shortcut for multiplication. So basically what you need to know to start off with for an exponential function is an exponent has a variable, which is the unknown number, and the variable is always in the exponent. The variable is always in the exponent. So an example of that would be y equals 3 raised to x. Okay? The number that's at the bottom is my base, and then we raise it to the variable, the unknown. So I could put a 0 here, or I could put a 1 here. I could put a 2 here. I could put 100 here. It tells me how many times that 3 is going to be multiplied. All right, so let's kind of talk about the formatting. So when we talked about exponential, or when we talked about linear functions, we had a couple of formats. We had y equals mx plus b, which was slope-intercept form, and we talked about ax plus by equals c. That was standard form. Well, exponential functions also have a format for its function, which is going to be a times b, and that's going to be raised to x. Now, the a and the b mean something, so we need to make sure that we are able to analyze what they mean. So the a value is the number being multiplied in front of the b, and I'll explain what the b is in a second. The a value is the y-intercept. It is the same y-intercept that we would discuss when we talked about linear functions, just labeled differently. It's also the initial value. So the a value is the initial value, the y-intercept, just like it was with linear. Now, what is it being multiplied in front of? Well, the number at the bottom of the exponent or the base, or the exponent or the variable is called the base. Now, we also call that the multiplier. Why do we call it the multiplier? Because it's the number that's being multiplied each time. So the base is the number that is below the exponent. So the base is always what's below this variable x or the exponent. It's the base, but it's also the number that's being multiplied each time. That's why it's called the multiplier. Now, the base can tell us something very important, just like the slope of a line can tell us whether it's increasing or decreasing because it's positive or negative. The base can tell us whether it's increasing or decreasing, but we normally don't call it increasing and decreasing. We call it growth and decay. So the base describes how the function will grow or how the function will decay. Now, there's 2 rules that go along with that. So if I have a exponential function that represents growth, that means it's going to go up in value. Then my base, my b, has to be greater than 1. Okay, my base has to be greater than 1. It can't be equal to 1 because 1 times anything is just going to keep repeating that same value over and over. So if it's growth, then the number that is below the exponent, the base, is greater than 1. If that number is greater than 1, that means we're multiplying by a number greater than 1, which means it's going to grow. So then we have decay. Now again, decay just means decreasing, means it's going down. So my base is less than 1. However, my base can never be negative, so it has to be greater than 0. So no negative bases. All right, so again, if I'm multiplying by something, a number that the multiplier is greater than 1, it's going to represent growth. If I multiply a base that is less than 1 but greater than 0, no negatives, then it's going to be decay. You can always look at the base and tell me whether it's growth or decay. Now let's look at, go back to this original problem. Now if you notice in this original problem, there was no a value here. So normally we would say y equals a times b raised to x. So the base in this problem is 3, but what is the a value? Okay, so when we look at the a value, we're asking ourselves, there's nothing here. Okay, there is something there, and it will always be a 1. You can't multiply by 0 because anything times 0 equals 0. So whenever you don't see an a value, your a value is automatically 1. So we're going to look at a couple of equation examples. So my first one is y equals 2 times 5 raised to x. Now, when I look at this, I should be able to say, I know that my y-intercept, my a is 2, and my base, my multiplier, is 5. Now, because my base is greater than 1, my 5 is greater than 1, I can say that this represents growth. I know that this is going to grow because my base is being, or my numbers are being multiplied by 5. Now, same situation can happen if it's decay. We just have to be able to look at it and see that it's less than 1. Now, you can use parentheses or you can use the multiplication symbol to represent multiplication. So again, my a value is equal to 2. And then my base is going to be 0.88. Now, my base is less than 1, so 0.88 is less than 1 but greater than 0. So that's going to represent decay. We know that the values that we multiply by are going to be going down. Now, what does growth and decay look like? So on a graph, it can't go below 0, so it's going to it's never going to actually reach 0. It's just going to kind of fall along, and then it's going to shoot up rapidly. So it's going to fall along that x-axis like a little tail, and then it's going to shoot up rapidly. Now, if you notice, it has like a J shape. Now, since it has that J shape, it's going up from left to right. So anytime you see a J shape, you need to remember that that is growth because it's going up from left to right. Same thing kind of happens with decay. It starts off at a higher level and then it's going to decay and level back out because it can never go below 0. Now, if you notice, this one kind of has an L shape. So the L shape is going to represent decay. Now, you do not have to write this down necessarily, but just to kind of talk about it, if I have y equals 0.94 raised to x, I do not see an a value in front. So my a value is automatically a 1, and my base is always the multiplier, the number below the exponent. So my base is 0.94. All right, I could have... All right, so here's another one. So my y-intercept is 5, and then my base is 1.02, and that is greater than 1. So it might be slightly greater than 1, but it's still greater than 1, which means it is going to represent growth, okay? So before we actually go and look at some more examples, we're just going to talk about some non-examples. So we talked about linear functions. So remember, a linear function is a straight line, whether it's going up or whether it's going down. And the key is that it is constant. That's the reason it's different, because it's the same change every single time. So when we looked at linear functions, remember our equations were very similar. Or they are the same as what we've talked about previously. Y equals mx plus b was one of them, or it could be ax plus by equals c. There's no exponents in those. Another function that we're going to get to right here at the end is going to be a quadratic function. Now, a quadratic function can be U-shaped or N-shaped. If it's flipped upside down, it can be either one, honestly, depending on how it's opening up. So that is called a quadratic function. And a quadratic function does have an exponent. However, the exponent and the base are different. So the exponent is going to be a number, and the base is going to be the variable. So the base is always 2. The exponent is always 2. So there's a flip-flop in the way that it's formatted. So again, if you notice here in the exponent, I have the variable. Here my exponent is a number. Here my base is a number. Here my base is a variable. So that's how they are different from each other. All right, so let's actually go and look at a chart, and let's just kind of look at the key features that we've discussed in different formats. So on this side, we have the y-intercept. So my A value is the y-intercept, the initial value. My B is my base or my multiplier. That's what we're going to multiply by each time. So when we look at an equation, we just kind of talked about this a second ago, but when we look at an equation, my A value is always the number being multiplied in the front. And again, that A value is my y-intercept. Just remember, if you do not see the A value, it's automatically a 1. So we just kind of talked about that just a second ago. But if you do not, let me zoom in here. If you do not see an A value, and again, the A value is the y-intercept, it is automatically 1, not 0, 1. Okay? All right, so then we have the base. So we talked about the base being the multiplier. So the key to the base is that the base is the number that's being multiplied, but it tells me whether it's growth or whether it is decay. All right, so again, if my base is growth, then we know the base is greater than 1. If my base is decay, that means it's going down. That means that it's going to be less than 1, but still has to be greater than 0. So that's just a simple identification from the equation. Now, how do we identify these same key features from a table? So remember, in a table, when we talked about linear, we said that to find the y-intercept, the A value, regardless of whether it's linear, exponential, quadratic, any function you talk about, the A value in a table is always the y value when x is 0. So the A value is the y-intercept and is the y value when x is 0. All right, so if I look at this table, I should be able to clearly see that my x value has it does have an x value of 0. So if I look here, my y value that goes with that is 1. So that means my y-intercept, my A value is 1. Now, when you look at the base, the multiplier, so remember it's called the multiplier for a reason. And that's because what number are we multiplying by? So we're looking for the base or the multiplier. And you need to ask yourself, what is being multiplied by each y value? So what number is being multiplied by each y value. Now, the other thing that you've got to make sure of is when I do this, they have to be, I need to check my x's out first though. So when I look at my x's, I need to make sure my x's are in consecutive order. So that means in order, so they're like 1, 2, 3, 4, and they need to be going up from least to greatest. So -1 to 0, that's consecutive, 0 to 1, 1 to 2, 2 to 3. Those are going up and they're in consecutive order. So as long as they're doing that, I can look at my numbers here and I can ask myself, what am I multiplying by to get from 0.5 to 1? What am I multiplying to get from 1 to 2, from 2 to 4, and 4 to 8? Now, a lot of times students are like, I don't know what I need to multiply by to get from 0.5 to 1. Well, that's okay. Go to the next one. 1 to 2 means we're multiplying by 2. 2 to 4, we're multiplying by 2. 4 to 8, we're multiplying by 2. And you can always go to Desmos and check and say 0.5 times 2. That is, in fact, giving me a value of 1. So my base is my multiplication number, my multiplier. So my base is 2. Now, if you can do that with tables, then graphs are very similar. You just have to create your own table. So the y-intercept is the same no matter what type of function you have. Where is it crossing the y-axis? So you always ask yourself, where is the graph crossing the y-axis? All right, once you find that number, that is your y-intercept. Now, I've labeled the points here for you, but again, when you do make your table, you have to find perfect points. You want perfect points. And those perfect points need to be listed from least to greatest and in consecutive order. So we start from the left side of the graph and we're going to go this way. We're going to go left to right like we read a book. So from the left side, the first perfect point I come to is at 0 and 1. All right, so I'm going to keep going to the left, and then the next perfect point I have in consecutive order is 1, 2. And then finally, as I keep going to the right, my next one is going to be 2 and 4. So again, you can see that they are in order, so 0 to 1, 1 to 2, and they're going up from least to greatest. And then all I have to do is ask myself, what am I multiplying by? 1 to 2 is times 2. 2 to 4 is times 2. So remember, exponentials is multiplication. This is not linear. We're not adding or subtracting. We're multiplying here. So since we're multiplying by 2, that means my base is also 2. Now, at the end, now that we've done all this, I can actually, all of these were the same representation. So I have a 1 and a 2, a 1 and a 2. I can actually write the equation and say 1 times 2 raised to x. Or more than likely, they're just going to say 2 raised to x. They don't normally write the problem with the 1 in the front because that's the understood one like we talked about before.